All right, welcome. This is me, a pen tester in the field, struggling to solve an HTTP box today. The box is called Administrator, and it's an old box which is supposed to be Windows. So, a few things. First, I always like to check with a ping. The detail is 127, which points to a Windows box. Um, The second thing is we have a username and a password provided. The username is Olivia and the password is this. So I like to do some password spraying at some part of the engagement. So I'll just create a separate file for the username and the password. And also I'd create Olivia and the password in a file called creds.txt. It's always easy. Uh, let's start with the Rust scan. Now I need to copy the IP, my bad. So the reason I like Rust scan is because it's extremely fast. And I can do nmap with just the open ports with the Rust scan. So I'm just gonna do nmap all. This first part basically is Rust scan trying to identify the open ports. Second part is feeding those open ports into nmap and doing a more thorough scan. We can see how quick it is. We already have a bunch of ports listed out for us. I don't see any 80 or 8080, which means there is no web, which is always fun because I am a red teamer. My specialty is in enterprise security, so I absolutely love internals without any web. We have 21, which is FTP, I believe. 53 is DNS, 88 Kerberos. Um, these are all NetBIOS. 445 is SMB. So it seems to be a domain controller because the Kerberos port is open. Now, a single box will never represent an entire Active Directory network. It doesn't work that way. Active Directory is called a network because there has to be multiple machines in the network. There has to be multiple servers, computers, databases, whatever it is in the network for it to be called an Active Directory system. Definitely, it's a CTF, and we cannot expect everything to be exactly realistic. But I'd say it's a domain controller, and that gives us an opportunity to enumerate and exploit some Active Directory related vulnerabilities also. All right, just to confirm it's a domain controller, you can see port 88, Kerberos, also LDAP 389, 3268 LDAP. These things, usually LDAP is open in domain controllers. These things point out to that. We have DNS. That is also very default to domain controller because generally in an Active Directory network, the DNS, the domain controller would do all the DNS for the entire network. And look at that in this LDAP. And also in this LDAP, we have the details that it is actually a domain which is called administrator.htb. And I bet this computer is called DC in some way, probably. Um, I don't see that in the in-map scan, but I could be blind. So we're gonna double check that as well. For domain controllers or Active Directory network, my methodology is pretty simple. I like to test and enumerate LDAP. I like to enumerate 445, which is it says Microsoft TS, but it's SMB. And also FTP is interesting because we don't usually see FTP. So we're definitely going to take a look at FTP as well. 5985, this is the HTTP API, the way Windows deals with WinAPI calls. This is not actually HTTP. This is not like a website that we can take a look at. Same goes for 47001. These are all MSRPC, which is remote procedure call, some low-level stuff that Windows does. All right, let's start our enumeration. Let's get the easy thing out of our way first. So FTP, I always like to do this to see if I can do some anonymous login. It says login failed. Okay, all right. Let's just get out of here. If we don't have a specific version, it's Microsoft FTPD. If we had, probably would do some other stuff. We can always come back to this, but I'm actually more interested in 445 and LDAP because those give me the most bang for buck all the time in Active Directory hacking. It's a domain, so we're definitely gonna add the domain name to our etc hosts file for better resolution, I guess. So administrator.htb. Now there is a way to actually figure out the host name, which is to enumerate SMB. So let's start by enumerating SMB, and then we can take a look at LDAP. For SMB, LDAP, any kind of Active Directory stuff, I love this tool netexec. We can call it by NXC, and we can just say NXC SMB because that's the protocol we want to look at or enumerate. And I'm just going to start with null authentication, where we don't really have username password. And this plus means we are actually authenticating successfully. SMB version 1 is false, which means SMB is pretty secure, at least the SMB version. Signing is true, doesn't really matter because we, in a huge Active Directory network, signing is really important because then you can introduce the ideas of Microsoft NTLM relaying or SMB relaying. But here, I don't think that's going to be a vector. So in a relay, you basically need more than one machine. So you capture authentication from one machine and relay to another. It's a single machine network, so uh, that's not gonna provide us with anything. So as the authentication worked, I would like to see if we can get a few information out using this null authentication. Users, password policy, and shares. And this is a very common scenario where null authentication would work, but enumerating shares or any sensitive information is usually blocked. We're seeing exactly that here. I like to check a few other things, for example, guest authentication, and see if that works. Nope, the guest account is actually disabled, so that's cool. I also like to check with a nonsense username and see if that does anything. Nope. It treats it like any other username and just gives us a status log on failure. Um, cool. Another thing is we can see the host name DC that I was mentioning. By enumerating SMB, we can actually figure out the host name as well. So we're gonna add that to our host file. So I'm gonna put DC here and also dc.administrator.htb. Why? Because this is how in Active Directory Network the FQDN or the fully qualified domain name of the machines are spelled out. So it would be the machine name dot the domain name. There are more complex concepts such as forests and trees, which go beyond the idea of domain, and that also has a pretty similar naming convention, but we're not going to get into that, at least in this video. So I don't think we're going to find anything from SMB. So let's go to LDAP and see if we can find anything. Again, I'm going to try with um, null authentication. We can see that there's an error that says LDAP error. In order to perform this operation, a successful bind must be completed in the connection. So a bind basically means a login, and we are using null, so we cannot log in. It's basically telling us that. However, we see this plus sign with LDAP. Um, why don't we try this and see if it gives us anything? So it always is going to like authenticate, but it's not going to give us anything. All right. That's all with our null authentication checks with SMB and LDAP. Now, remember we had threads. So it's time to use the creds. So we're gonna do the same checks, but this time with the creds. So this is my IP. I'm gonna put in the username Olivia and the password. Now we can always mention the domain with tag D, but I'm not gonna do that because from this IP, the domain name is kind of given. NX is smart enough to figure that out by itself. So we can see the output. Now this is the shares output, enumerated shares, and this looks pretty default to me. These are all the default shares that we usually see in a Windows SMB. So not much of nothing too interesting actually. We have a list of users, which is cool. We can grab the user list and we can do like a password spray, see if the same password works for anybody else. We also have the password complexity, and I always like to check that out because it helps. The way we read the password complexity is that minimum password length is 7, which gives us a hint towards password spraying. We don't want to spray anything that's less than 7, then it's a waste. Um, Password history length doesn't really matter. The other thing that matters is the password complexity flag. We can see everything is set to 0, which means none of the complexities have been applied. So that's pretty insecure. Reset account lockout would be 30 minutes. So if we lock an account out by doing excessive password spray, we're going to be logged out for 30 minutes. And oh, so sorry, that is the duration. And reset account lockout counter would be how many times do we have to mess up for that. Lockout threshold, none. That means we can try the logins and password spray for as many times as we want, actually. So pretty cool. Now, what we're gonna do is we actually want to grab this users list. Now I can copy these lines and try to grab it this way. But let's do something else. Let's use our tools a bit better, right? We're gonna do export users, users.text. Okay, that was not the right command. I think it's users export. Yep, that's the right command. So we're still getting the same users, but this time everything has been written to users.text. Cool. Now let's use another tool called Kerberoast. I don't have that installed, but I have that in my tools folder. Okay. Using Kerberoast, we can do a few things. We can do a password spray, which is cool. We can do a user enumeration just to see if the user list that we have are valid users or not. This is useful when you have a very long list of users and you don't really know if they're valid or not. But we literally pulled these users from the DC itself, so they're valid users. I don't have to do that, but I'm still gonna do that because I want to show you something. User enum, and we're just gonna put the users.txt file, and we're gonna mention the domain as administrator.htb. We are also going to put the DC in. So that would be our IP. All right. So we can see it tested 10 valid usernames and 6 are valid. So by default, the users like administrator, guest, Kirby TGT, Olive, these 3 are going to be called out as bad users and they wouldn't show up here. It's fine to work with these users, but yeah, I'd like to keep my options on. Actually, they Carver decided to throw out a few other users as well, so it might have some merit to it. Let's edit our users of text file and take out the users. KRBTGT would be out. Olivia is there. Benjamin is there. Emily is there. Ethan is there. Alexander is not there. Emma is not there. So 1, 2, 3, 4, 5, 6. Yeah, let's work with our users. Now let's do a quick password spray and see if I've got anything with these users or not. So again, we're gonna go back to Kerberoast, and this time we're gonna do a password spray with this users list, and we're going to mention our password. Our password was this thing, and see how it works. Tested 6 logins and 0 success. So the way it works is it basically is Kerberoast is basically doing everything over Kerberos instead of NTLM authentication or SMB authentication. And I just like Kerberos better because in this type of authentication method, the risk of getting logged out with the users is lesser. So yeah, that's the main idea of using Kerberos, using Kerberoot. We could have done the same thing with our SMB, with our NXE tool over the SMB port. The process would be to do this. Yeah, so this does the same thing basically. Uh, so whenever it finds a valid user, it stops. Now I like to do continue on success and see if this gives us anything. It doesn't. That's pretty weird. Oh no, it's not. I was looking at this part and thinking that okay, maybe it was spraying the same user over and over. All right, let's clear this out. So far we know that we have 6 valid users, but I'm actually tempted to still look at the other users. Kerberoot could be giving us a false positive. I don't know. So yeah, that's there. We did a password spray, nothing turned out. Now it's time to do some Active Directory specific attacks. What do I mean? I mean this. We're going to put a user that was Olivia. So instead of SMB, we're going to target the LDAP protocol and we're going to do an AS roast attack. AS roast attack would be an attack where we're trying to find out users who do not require a password to log in via Kerberos. I can go into the details of it, but I don't want to because we did not find this attack vector here. Maybe in some future box, I'm going to talk about that if we find it. Then we're going to try the Kerberoasting attack. I hope this gives us something. It doesn't. Pretty interesting. So Kerberoasting would be another attack where we're targeting service accounts and seeing if any user account is actually a service account, and that we can grab that account's hash by targeting a TGS ticket. That is also probably discussion for another video. Um, all right, let's try some other stuff. When I don't usually have anything from this too, I like to check for ADCS. I forgot the flag for it. ADCS enum or something like that. I remember because I usually here it is ADCS enum. Oh no, it's a in. Oh, so we can just do this. It should work. Yeah, it works. Yeah, so I like to do ADCS enumeration with CertiPy. I'm not familiar with the NXE thing, but yeah, it says it tried to search in LDAP, but it couldn't find any ADCS infrastructure. Okay. My next thing that I like to check is actually a Bloodhound scan. Now, there are a bunch of ways to do Bloodhound, and sometimes it gets confusing. There are 2 parts to Bloodhound. So first, there is the ingesture. How do you call it? I don't know uh, not the ingesture. Yeah, okay, whatever. Which basically collects data from the environment, and there's this GUI part where you basically view the data. And also for each, there are 2 versions. There's the Bloodhound Python version, Bloodhound Python CE version, and also there is a Bloodhound Legacy version for GUI, and there is a Bloodhound C version. I say always go for both C. C basically means community edition, and this was the later version that I think Spectre Ops created Bloodhound. But yeah, they came out with. Now we can run Bloodhound using an XC, or under we can actually directly run the ingester. The idea is we first run the ingester to collect all the data from the environment and then basically view the environment in a very nice way. So we can either do it with NXC, or we can actually do it with Bloodhound C Python. Under the hood of NXC, this tool is running. So why not run it with like directly, right? So we did the username, we did the password. Let's do the administrator.htb domain. Um, then I like to do DNS TCP so that the DNS work is getting done over TCP. I like to do tag C all logged on. Tag C would be collection method, and I would like to incorporate all collection method. I want all the data. And very weirdly, logged on data is not collected, even if we mention all. So I like to do it separately. I like to add it separately. And we want to do a zip because we want everything. Like Bloodhound creates a bunch of JSON files, and we want all of them to be uh, nicely put together in a zip file. We can run it like this. So it says could not find a global catalog server, assuming the primary DC has this role. The primary DC would be this DC, right? Okay. Failed to get Kerberos TGT, falling back to NTLM, and there is this connection error. Could not find a domain controller. Consider specifying a domain or a DNS server. Now, this is a very common known problem with Bloodhound with finding the domain, so the domain controller. So what I'm gonna try with is I'm gonna try with specifying the NS, the name server, or the DNS server, and see if it works. If it doesn't, I have other things to do. Okay, it says server DNS operation timed out. Okay, I like to do one more thing before trying anything else, which is this DC thing. So I can do tag DC dot administrator dot htb. It didn't work. So let's specify tag k, and tag k basically, hold on, I'll just remove these things. So tag k basically tells Bloodhound to use Kerberos, and instead of NTLM authentication, do everything over Kerberos. So we're gonna see if that works. Again, could not find a domain controller. That's interesting. We're gonna try with this. See if it works. Nope. Am I putting in the IP correctly? Yep, it's correct. That's annoying. Let's try to remove our DNS TCP option and see. Okay, it seems it's working. So our DNS TCP flag was the issue. Um, Probably it's configured to use DNS over UDP or something like that. Or I was just missing something very obvious. Like, yeah, I was missing something obvious. I think I put one tag behind DNS TCP. Look, oh my God. Okay. All right. So it's done. It gives us a few information, like the LDAP server is this, one domain, one domain in the forest, 11 users, 53 groups, 2 GPOs. Now, this is something that I was talking about, 11 users, right? But Kerbero told us only 6 of the users that we mentioned were valid, so it might be a false positive. We don't know. Found 53 groups, 2 GPOs, 1 OU, 19 container. Cool. We have this zip file. If we ls, this is our zip file. So let's just name it. Let's just say Olivia Bloodhound.zip, right? And what I'm gonna do is I'm gonna run the Bloodhound GUI in my Windows machine, and I'll just drag it over here so that you guys can see it. And I'm doing it because Bloodhound GUI is pretty heavy, and it doesn't really like when you run it inside a VMware VM because it's just nuts how it works. Okay, I might need to blur that out. Um, I'm just gonna cut this part. So we're gonna open the directory. We're gonna copy it over to my computer, and we're gonna open it, and we're gonna try to drag it in. You see, we have dragged it in. We hit upload, and the files will be ingesting for some time. Now, Bloodhound GUI, the best way to look at it is going to administrator, and this is all the files that you basically upload. Um, it's ingesting, so it's doing its work. It's visualizing all the data for us, and there should be like six, seven files. That's the typical number. While it ingests, it's analyzing now. While it does that, I like to mention a few things, which is the best way to get Bloodhound and Bloodhound GUI is this. So if you search Bloodhound Dark Janem, you're gonna see he has a way to install both Bloodhounds, Legacy and CE, and these are the ingesters. I say go with pipex because it handles all the libraries and Python nitty-gritties. You don't have to check out anything. I also pull netexec via pipex because I love it so much. And also for the GUI, Bloodhound C install. This is Spectre Ops and they have it documented really well. So the visual I'm showing you here is basically the GUI. First, I like to look at my user, Olivia, right click, add to owned. Add to owned basically tells Bloodhound that, okay, I own this user, I have access. Then there are a few things. Pathfinding is where you go with specific ideas in mind. Say from Olivia, you want to reach the administrator user. You search for it, it says path not found. So we cannot just blindly do this. If we have a specific mind, a plan in mind that okay, XYZ user might be interesting, we can try that here and see if we can reach that user, and from that user we can move forward. Then the ciphers. Ciphers are basically another way to really narrow down our data. These are all the saved ciphers, so we can hit all domain admins. In the backend, it runs this code, and as a result, it tells us this information. Map domain trust. And there are lots of ciphers, map OU structures, stuff like that. Um, a few important ones that I like to try, all Kerberoastable users, no results match your criteria. We already know that because we didn't find anywhere we did the Kerberoasting attack. Is reprostable user, again, no results because we did that and we couldn't find any. Shortest paths domain admin. This is interesting always. Now, the problem with this cipher is that it's not really, you know, specific, specific to our user that we own. It just tells us the shortest path. Um, in a complex big network, this would be a mess. You wouldn't get anything out of it. But from here, we can see that Emily has generic write permission over Ethan. Ethan can DC sync, which basically means he can dump any credential from the domain controller. And that means he can just dump the administrator credential and get domain admin. So this looks really interesting. Now, what I like to do is I like to show you another thing here. Um, I'll just search it, shortest paths from owned objects. Now it's more specific. We own Olivia. Olivia has generic all over Michael. Michael has force change password over Benjamin, and Benjamin is a member of share moderators. That is one way of escalation. Share moderators must be a cool group, right? It must have some privileges. Okay, that's one idea that we have, and through this idea we can reach Benjamin. Okay, we go back to pathfinding, and remember, in our shortest path cipher, we had Emily, and from Emily we could actually get the domain. So I'm interested to see if my user Olivia can reach Emily. Path not found. Okay, all right. So from Benjamin, because remember we could reach Benjamin from our user. From Benjamin, do you have a path to Emily? We don't. That's cool. I guess we just have to work with what we have right now and go with the shortest paths for now. We take over Michael, we take over Benjamin, and enumerate more from their perspective and see if we can find anything new, right? Because we clearly don't have a direct path to domain admin or like a domain takeover at this moment. Really cool thing about Bloodhound is that it really maps out everything for you. From Olivia, you can do a generic call over Michael. Now you ask, what is generic call? Okay, Google it. Generic call Privist, right? And you have a lot of blogs. Or the coolest thing is that you can hit generic call and literally read about it. The general information, Linux abuse, how to abuse this in a Linux setting. They listed out three ways: targeted Kerberoasting, force change password, and shadow credential attack. Now, force change password would be the easiest because you can literally change the password for Michael and say call it a day. But in a real engagement, they wouldn't let you do that. You need to talk to your client before doing that. So I usually go with shadow credentials, but it's a bit more complex attack, and you don't need to know that. You don't need to make your life more complicated in a CTF setting. So I'm just gonna do this generic all abuse over Michael by changing Michael's password. I can do it using this, or I actually have a better way of doing it. So let's do it that way. That is using NXC. I told you I love NXC. So the idea is we go to NXC doc and we search with change user password, and it tells us how to do it. So we do NXC, we do it over SMB protocol, our user, our password, tag M, change password, tag O, our target user, and new pass. Looks pretty simple. Let's try that. NXC SMB, I'm just gonna put in Olivia for password. Do I have it right here? Gonna put this one in. For module, I'm gonna say change password, tag O, target user would be Michael. Dude was Michael, right? Michael. Yep, Michael. Um, New pass would be password 123, and we have invalid choice, change password. That's because we need to do this. We did this, right? Oh, I did an underscore. That's embarrassing. So this is the right name. Change hyphen password. Successfully change the password for Olivia. It should say change the password for Michael actually. I don't know what happened there. Target user, is this correct? Oh my God, it would be user. So we accidentally changed the password for Olivia. That's interesting. So let's our let's use the newly changed password 123 for Olivia, and then this time put in the right flag, hopefully. So it's user, the flag's name. Now we are targeting the user Michael. We are creating this new password for Michael using our privilege of Olivia. And we can do this because we have generic write permission over Michael's account. Now, generic write, just to explain a little bit about it, it basically means that you can write to different attributes of the object Michael, and one of the attributes is definitely the password. So we're basically rewriting the password attribute so that we are essentially changing the password for Michael. You can definitely read more about it. Um, it's not a deep dive, so I'm not getting into it that much. So now we have Michael, right? Let's test it. 129, 1758, tag Q, Michael, tag P. It should be password 123, right? Let's see if it works. Look at that. It works. That's pretty cool. All right, so we have boned the user Michael. From here, I like to do a few things. One, go back to my BloodHound, find the Michael user, and also say, I own this user. Cool. Second thing is run another BloodHound as Michael because we want to enumerate the entire domain as Michael as well. Oh, I put the password wrong. Why am I doing this? Because I just like to have good view of the entire domain. Now, something really interesting is that Kirby AP error skew clock skew to create, which basically points to this error when we have when we're doing anything over Kerberos. Kerberos is a very sensitive time sensitive protocol, so we need to make sure that our the times between my VM and the targeted domain controller is similar within 10 seconds. There's a very easy way to do that. We can just do sudo ntpdate and our domain controller IP. It basically syncs our clocks. All right, we have the Bloodhound output here, and I'm just going to move it and say it's Michael bloodhound.zip. Cool. Remember, we could actually, from Michael, we could actually take over something else. So if you go to Michael, there's another way of looking at what we looked at earlier, which is this outbound object control thing. And see, Michael can force change password for Benjamin. We're going to do that. We're going to take over the Benjamin user as well because why not? So let's go back. And because it's a force change password, we can essentially do the same thing we did with while changing the password for Michael, right? Because it's the same thing. So we're gonna say tag m change password. This time we want to target the user Benjamin, and we want to put the password as password 123 as well. So as Michael user, we're targeting the user Benjamin. We're changing his password. We can do that because we have force change password capabilities as Michael over Benjamin. Successfully changed password. Let's test it. Um, the user would be Benjamin. See, we have the plus. And you know what I like to do? Go back, right click Benjamin, say add to owned, and also run another Bloodhound as Benjamin because I like to view Active Directory with as much information as possible. We have the Bloodhound output. We're going to move it, call it Benjamin bloodhound.zip. If we open this, again, we have Michael and Benjamin. I'm just going to copy this to over to my machine, paste them, and in Bloodhound, I'm going to go to quick upload and I'll just drag them over. So we can do this on the same Bloodhound, the same Bloodhound that is holding Olivia's information. So we have uploaded them, they have uploaded 100%. We can go to administrator and it's ingesting. While it ingests, let's explore a bit more. We have taken over Michael and Benjamin. So let's see if we find anything. Principals with GC sync privilege, Ethan has that. GC sync basically means we can uh, take advantage of the syncing process between different domain controllers and ask to pull the passwords from the NTDS database file from the domain controller. NTDS holds all the users and their passwords, basically their hashes, not the passwords, but you know what I mean. Servers where domain users can RDP, nothing. Dangerous privilege for domain users group, nothing. Um, Shortest paths from owned object. I'm trying to see if anything changed because we own like two more users now, but nothing really changed. Um, this claim special identity basically means we can claim this identity for a second, like for a temporary amount of time. Usually they don't provide with like anything, so I'm not looking at them. Uh, let's go back to our administrator. It's completed. I'm gonna come here and refresh Bloodhound once. And now we're gonna check with all the new information that you have loaded in. Do we have new shortest paths to domain admin? Nope. Still, Emily has generic right over Ethan. Um, Shortest paths from owned object. Nope. We still don't have a clear path to domain admin, domain controller, or anything interesting. Okay, let's go to path finding. Now, as we own a few different users, we have already checked Olivia. Let's check Michael. Does Michael has any path to this administrator user? It doesn't. Does Michael has any path to this domain administrator? It doesn't. What about Benjamin? Does Benjamin has any special relation to the user administrator? Doesn't. The domain? It doesn't. Okay. Let's go back to Olivia. Let's check Olivia's ACLs out or outbound object control. We already know this. Olivia can generate call to Michael. All right, let's select Michael and let's check Michael's outbound. Michael can change password for Benjamin. Cool, we knew that. We took care of that. Let's go to Benjamin. Doesn't have any outbound object control. Cool. We're kind of hitting a dead end now. From here, let's try to enumerate the domain more from the perspective of Benjamin and Michael. So I'm gonna do is SMB IP. We're gonna do Michael and we're gonna try to search up a few things. For example, let's search domain shares. Does Michael have any specific access to any domain share? Nope, it's the same access we had with Olivia. What about Benjamin? Nope, same. All right. From here, I want to try something else. I want to try a password spray against different protocols, different services of this domain controller. So if we look at our nmap, we can see LDAP is open. SMB is open, and we have tried to spray passwords against this too, right? RPC is open. We did not try password spray against that. WinRM and RDP is usually open for Windows servers. 5985 is basically WinRM. So we can try spraying password against those, right? Just to make life simpler, I like to write this quick script. I don't know if you can call it a script. So trying to see as Benjamin for all these protocols, and I'm gonna add LDAP into the mix as well. On our domain controller, the IP for the domain controller is here. Do we have any success? So for SMB, yep, we have a plus. For RPC, yep, we have a plus. For LDAP, we have a plus. For WinRM, we don't. Okay, let's check this out for Michael. What I'm trying to see is exactly this. That's pretty cool. So see, with WinRM protocol, as Michael, we have pawned on this server. What does it mean? We're using NXC, so let's go to NXC doc. Let's go to using credential and see these are protocols. If you see pawned in the output, if it's on WinRM, it means you can at least execute code. Why does it say at least? Because the ultimate thing is if this user is an administrator on this machine, then beyond executing code, you can actually dump credentials over WinRM. How do you do that? We go to WinRM protocol, you search for obtaining credentials, and you can dump the SAM database, the LSA database, and also DP API, right? So what we're going to do is first we're going to validate that can we execute code? What does it mean by executing code? It means we can execute command because at its core, all the commands are codes, right? So we're going to do WinRM. We're going to do not administrator because it's a bit confusing, I guess. So we're just going to use the IP. We're going to use the user Michael. We're going to put in its password and we're doing it over WinRM. And we're going to do this tag C. Who am I? You can see pwned and it gives us a result back. On the administrator machine, you are Michael. Pretty cool. Okay, so we can execute code. NXC was not lying, but can do we actually have like admin access? For that, we can try to dump creds, and if we can, that means we have admin access. Otherwise, we don't. Okay, so let's try to dump creds. Tactic LSA, tactic SAM. Nope, we couldn't. They're asking us to try the dump method. That means there are different methods of dumping the code, not the code, the credentials. And we're gonna try a method like PowerShell. Mm, mm, Dump method. I'm just trying to see if I can show you um, the documentation for it. Executing methods. I don't think we have. This is a pretty cool AMC bypass thing, but it's fine. We don't need that. Dump. Yeah. So now I'm putting in dump method as PowerShell. Does it work? It doesn't. It says fail to dump SAM. It may have been detected by AV or current user is not a privileged user. Nine times out of 10, I'd say it's not a privileged user because it's a CTF. AV is probably not that prominent. We can actually check that out, you know. We can search for AV, enumerate antivirus. We can do this flag and it will tell us if it has AV or not. This machine has AV or not. So we do tag m, enum AV. Uh, I cannot type. It's not supported for WinRM, so we're gonna try it with SMB because it says this is not a WinRM command in maybe. Let's see if we get anything back. But I bet there is no FE. It's just that's Windows different install. Look at that. I'm wrong. Awesome. So there's Windows Defender. So maybe Windows Defender is like spotting us, trying to dump SAM and LSA. I'm not gonna panic. I can go to like two different routes from here. One is trying to bypass the AV using an XC. You see AMSI bypass, that is some type of protection. We can bypass that. But I like to think that bypassing AV should not be required at this level. So the second path is using evil winrm to get a shell on the box. What is evil winrm? Evil winrm is a tool that we can use over the winrm protocol to get access to get a shell. So the same thing that we were doing with NXC, we were basically executing commands. Now we're going to do that in a much nicer way in a shell. Look at that. We have a shell. Who am I? I'm Michael. We're going to look at desktop, ls. We don't have anything. That's pretty cool. Let's go back. Let's go back. We have the user Emily, Michael, and admin. Admin is our target, right? We want to be admin. Um, Now, do you remember Emily had a pretty good path towards the domain admin? So I think I think the prefix vector for this machine would be from Michael to Emily and then to admin, or just taking over the whole domain controller. To do that, I will be heavily focusing on Emily and trying to see if I can figure anything out. Okay, it's denied. That's cool. Can we check the history? We can't. LSL wouldn't work. I have to do GCI force. Let's go to Michael. I like to check an interesting thing, which is PowerShell history file, app data, Microsoft Windows, PowerShell, PS Redline, console host history. So if we go to app data and if we try to hit this path, ls this path, it does not exist. We can do GCI force and it doesn't have a Microsoft directory. Uh, we can go inside local, then Microsoft, then Windows, then PowerShell, and I don't think we're getting anywhere with this. Yep, we're not. So this file was interesting because it basically contains the entire PowerShell history. All right. We didn't find anything. By the way, there is a way to grab it with NXA as well. I'll show it because it's just easy, to be honest. I did it in a hard way. I tried to do it in a hard way, but yeah, let's try that and see if it finds anything that I couldn't find, right? Michael, password 123, and the module where we want is PowerShell history. Again, if I'm not wrong. Let's see, history. Uh, The flag is called TechM PowerShell underscore history. Look at that. I got it right. Damn. Lol. PowerShell history is not supported for winner and we cannot check that. It's fine. It's fine. Can we check that with SMB? I don't think so, but yeah, we couldn't. Okay. By the way, we missed one thing. I just remembered. With WinRM, in obtaining credentials, other than SAM and LSA, we could also dump the DP API. Why don't we try that? Because sometimes DP API is also going to give you success. Okay, it didn't. DP API is basically this encryption thing. Uh, I'll go in the nitty-gritties of DP API in some other video where we actually explore that. All right, looks like we are at a dead end. So let's go to C, try to enumerate this machine, inetpub, cd logs, logs is denied, cd ftp root. Interesting. We have FTP. We actually forgot about FTP. So remember we had FTP? What about we try to access FTP as Michael? Will that give us anything? Could that be the next vector? So I'll do nxcftp Michael. User cannot log in. Home directory inaccessible. What about Mr. Benjamin? Can he? Oh, Benjamin can FTP. That's cool. So let's go back to nxcdoc. Let's look at enumerating FTP. Where can it be? FTP protocol. Authentication, we need authentication. Password string, we don't need that. Listing files would be tag-ls, files upload and download. Okay, let's do ls and see there is a backup file. Backup files are always interesting. So let's do it via nxc and try to download this file. Tag-get and the file name. So we'll do tag-get and the file name psafe3. We downloaded it. Another way of doing it, just do it manually. Do FTP 58, put Mr. Benjamin. For password, put our password. Do ls, we have backup, and just do backup, get backup PSAF3, and it will download the file. That is without NXC, how to do it. Now, I don't remember, I don't like recall this extension. We can do a file against this. It's a password save v3 database. So we're in for a treat. We are learning something new. That's cool. PSF3 extension. Let's try that. It's a secure database used by Password Safe. Okay, an open source password manager. So it's some alternative to KeePass because I have seen um, people using KeePass in this stuff. All right, so we're gonna do PS FE3, PS AFE3 pen test. There is a hashcat module. PS FE3, FE2 John. Okay, testing PS PSA FE3. It talks about the PS FE3 thing. Okay. All right. So it seems it's very similar to KeePass hacking. So basically, it's a secured database, and we need a master password to open this database. The process of doing that is first we have to do PSA FE3 to John, PSA FE3, PSA FE3. Yeah. Oh, I think it's not FE3. The command is pwsafe to John. Okay. So first we need to use John or John the Ripper. PSW safe. PSW safe or PW safe, I think. I'm looking at this. PW safe. Yeah. Safe to John. And basically extract the encryption part, put it into this hash. Now we have a hash and we need to crack it. So I'm just gonna copy it and you can do this with hashcat and do user share rockU.wordlist rockU.text w4o. Hashcat didn't work because it didn't find any GPU, which is normal because it's inside a VM. So using hashcat inside VMware, you can search, and it should say how to force it over CPU. There's a flag in hashcat forcing hashcat over CPU. Tac force. So we can basically do like this. Still doesn't work, so probably some type of protection. You can do it via John as well, which is John the Ripper. The process to do it is, I think we can just do John and the hash and the password file. I have not used John in ages. I have a pretty nice rig for cracking passwords with Hashcat. I just use that. But I don't want to show you guys my computer, so that's why I don't want to do that. I don't want to record that. Let's we're gonna do like a quick Google search. So crack hash with John tactic word list and hash file. Okay. So what we're gonna do is we have the hash. We're gonna do John word list user share word lists rockU.text, and for our hash file we have it in hash.text. Oh, that was pretty quick. This is the password for the database PSA FE3. Now we're gonna search PSA FE3 database and test just to see if anybody has any clear identify like way to look at these files, how to use the password and stuff. We found something cool. It's a pwsafe.js. It's a browser where we can view the file. I mean, that would be nice. It's not a browser anymore, guys. I have to download stuff. I don't want to download stuff. Okay. People are talking about opening it in Python. Let's look at this. So they are talking about downloading pwsafe. I'm gonna check pwsafe Pally. It's over at GitHub. Installation, or we can do it from GitHub. Um, or we can do it their way. Go to the release page of GitHub. So basically, the release page here, and we can grab the latest dev file, AMD64 deb. Cool. We're gonna move from downloads pwsafe to here. So I'm going to sudo dpkg tech I pw password safe. It should install the pw safe tool here. Wow, it didn't work. Did it? Or yeah, we're doing the right thing. We're gonna try it. Oh, we have PW safe. I think I don't know about this error. I'd have to take a look at into this. So the syntax is you do PW safe and your file. For us, it's backup. No such file or directory. Oh, okay. It couldn't load a shared library. I bet it has to do with our installation, right? So sudo apt. Actually, I'm gonna try it. Nope, there is no PW safe. Okay. Um, okay. So let's try to figure out how to install this better, right? We have the AMD 64 one, so should be good. It's we downloaded 12.1. What if we download 13.1? Probably it's a Linux version mismatch or something. It's downloaded, so sudo dpkg downloads pwc my auto completion stopped working. Interesting. Tech I downloads pw password safe. What about this? Does this work? It cannot install password safe. This package. Dependency problems prevent the configuration of this password. Okay, so we need to fix this. What dependencies are coming in between? This package is not installed. So I need to figure this part out, right? So let's copy this part. Let's Google it and see if this is a common error. Yeah, we can do the fix broken install. Um, yeah, let's try the quick sudo apt install. Let's try the quick fix broken install first, and then um, fix broken install that y. It's grabbing that, so this time it should work, right? There you go, worked. Now if we do pw safe, yep, something opens up. So we're gonna just do pw safe, and we'll do backup. We see our database loaded here. Our master password was John hash.text. I think it's show. Wow, I forgot to save my John password. Ah, John, how to see recovered password. I don't know the flags for anything. At this point, I don't know if I'm a hacker or not. John tag show. Yeah, I was right. But John hash.text show. It was this. And the user is back you, I think. Okay. So we do the master password. It's correct. We do okay. And we have a bunch of things. Alexander, Emily, Emma. Uh, display auth. Okay. So it looks pretty secured, I'd say. Open. No. Okay, so when I double click, you can see password copied. So I'm just gonna do a quick hack. I'll just grab it this way. I double clicked, I pasted here. This doesn't look right. I'll double click again and paste it. No, it's right. Okay. So we're gonna do this in our we're gonna do Alexander. What is the Alexander? Yeah. Alexander this to our threads.txt. And we're gonna double click Emily. Looks like this. We're gonna do Emily threads.txt. I feel like this is some encrypted or like hashed version of the password. Because I'm double clicking, I cannot see it. I mean, we can just go back to PW safe and check this out, right? There's a HTTP skill assessment for working with PW safe. So I'm just gonna see if I'm correct because this is the first time I'm working with this, right? So yeah, this is the same view that we have. So either this is a hashed version of the actual password. When we double click and copy, we just get the hashed version, or this is the password. Duplicate entry, delete entry, copy password to clipboard. Yeah, we get this weird password all the time. It was for Emma, right? Yep, it was for Emma. We're just gonna do creds.txt. Now let's check it out, right? NXC, SMB, and we'll do a password. We're gonna do Emma. No, doesn't work. All right. I mean, that's sad. Is it the same for each? Can we cat? Yeah, it's strings backup. Okay. So let's cat our creds.txt. And actually let's see. PW safe, right? PW safe database clear text password view, something like that. Reveal individual items or export the entire database to a text file. Right click, view or edit, and file export to plain text. Yeah, let's do that and actually test our theory if this is some type of um, weird thing or not. Are we getting the actual thing or not? So the actual password or not. So we're gonna copy our master password and we're gonna do pw safe backup, paste in our master password. Looks good. Um, come here and go to view, file, export to plain text. Yeah, why not? Yeah, unprotect copy of all the passwords. So I think we're looking at the protected copy. Yeah, we're just gonna put it in the text file. No, I don't want to see a detailed report. All right, so now if we cat the text file or open the text file because it's a mess, we can see group username password. Nope, this was the password according to them. Cool. If it's the password, we have to do with it, right? All right, so I'm just gonna keep trying with Emily and see if this works. Remember our proto command? Let's try that. This is the password for Emily. We want to spray it over everything. I'm just gonna do the host name here instead of the IP. Winner MRDP. We're also gonna do FTP. and also LDAP. And in another tab, I'm gonna do same proto thing, but this time with, I don't think this is working because um, we need to do tc.administrator.htb. This should work, yeah. Oh, look at that. It worked. And look at that, we have pawned as Emily over winner M. Okay, just for the peace of mind, we're gonna also try Alex, Mr. Alexander the Great. I'm gonna try this, and we're gonna do check you, Alexander, and we're gonna do dc.administrator.htb. We'll put in FTP as well as LDAP in here. But yeah, the other two are passed. So let's go to our creds file. Let's get rid of Alexander and Emma. We can actually put in Michael because we changed these users, and also Benjamin. These are valid creds, right? Okay, so this is Emma's password, and if you remember, Emma is one of our important users because if you go to shortest path to domain admin, you'd see, oh shoot, that's Emily, not Emma. Cool. All right. Was it Emily or Emma that I cracked? Oh no, that's Emily. Yep, back to being happy. So go to Emily, mark her as own. I mean, that sounds pretty bad, but we basically have the password to Emily. Um, and over WinRM, we have Pond. So I am just gonna indulge myself and I'm gonna check something. If this Pond means code execution or admin access, who knows? Sam, nope. Okay, dump method. I mean, let's try it, right? If the demigods are happy, we should get it. Nope. Cool. We still have like code execution, right? Cool, we do. So now again, two paths that we can take. One is definitely evil winner empire, and we put in our password, we put in our user, we put in our dc.administrator.htb. We exit out of this because we don't need Benjamin anymore. cd desktop, and we have the user.text. That's pretty cool. I'm just gonna quickly put in a flag. I'm solving this box for the first time. So um, now the first path is to actually trying to escalate our privilege on this machine on the domain controller itself, right? The second path, and I like that path more, that is to doing it via Active Directory. We own Emily. That means we can generic write over Ethan, and from Ethan we can desync to the domain, or we can grab every user, every credential, everything. We will own everything. Let's do it this way. We already know about generic write. We did it already as Olivia over uh, Benjamin. No, over the other user, not Benjamin. So we're gonna do the same. Generic write gives you the ability to do target Kerberoast, shadow credential, password change. So we're gonna try to do a password change and see if that works. So pretty cool. NXE, this, Emily password. That's not the password. Cat threads.text. Yeah, I knew it. NXC Emily password change password user would be Ethan. New pass would be you know it. Password 123 exclamation. Um, I'm just gonna make sure my goldfish memory didn't forget change password. Yeah, this should work. It didn't work. Why? Because when you look at Emily having generic right, and when you hit Linux abuse, you see the password change part is missing. When we did the other thing, when we did this, so when we went from where is it? Where is it? When we went from Olivia to Michael, we had generic all. Generic all means generic right plus some other stuff. That's why you could change password. But this is just generic right. So we need to do other stuff. What is that? We can do a targeted curb roast. Targeted curb roast means first making Ethan vulnerable to the curb roasting attack and then abuse that attack to take over Ethan. Let's do that. And while doing that, we will explain what curb roasting is and how does targeted curb roast attack works. We can again do it via NXC. Here is targeted curb roasting. So we do curb roasting, output.text, targeted curb roast, and our victim. So let's try that. I have never done it via NXC before, so it will be a new thing for me as well. So we're gonna do curb roasting, and we're gonna do like a file a.text where the hash will be saved, and we're gonna do targeted curb roast, right? Targeted curb roast. There is a double tag, and Ethan. And we need to change it over to LDAP because this abuse of curb roasting works over LDAP. Awesome. What is it? What is curb roasting? In Active Directory, there are service accounts, the accounts that are used to run services. The most secure way to do it is having dedicated service accounts that will just handle the services. But most of the times, what happens is we find user accounts that handle services. Why user accounts handling services is a problem? Because finding service accounts is very easy. All the accounts that handles a service, all of them will have this thing called SPN attached to them, service principal name. So we just do a search that, okay, how many SPNs are there in the domain? And these SPNs are connected to which accounts? Whichever account the SPN will be connected to, that account is a service account. Okay, that is the identification part. If you run a service using a user account, it's very easy to identify and understand that, okay, this user is running a service. But why is that problematic, or where is the problem? Like, where is the vulnerability? The vulnerability lies in the idea that whenever an account is running a service, in the Kerberos flow, when any user in the domain is trying to access that service, that user will get a TGS, a ticket granting service ticket. or a service ticket in short. That service ticket, part of it, will be encrypted with the account's password hash that is running that service. So to simplify everything, XYZ user is running a service. That's why any user in the domain can get a TGS which will be encrypted with the XYZ user's account hash. That's how it works. That's how Kerberos works. We, attackers, what we like to do is we like to ask for an access to that service. We like to ask for a TGS. We get the TGS, and the TGS is encrypted with the service account hash, right? So we basically take out the encrypted part, we brute force it, and we basically try to figure out the service account's hash, service account's password. Clear? Okay. What is targeted Kerberoasting? Now, if this domain had Kerberos, if this domain had service accounts and we found those, that would be just Kerberoasting. But in this attack, what we did was we intentionally attached an SPN to the user Ethan. It has a SPN. That means it's a service account. That means we can ask for a TGS. That means that TGS will be encrypted with Ethan's password, and we take the encrypted part out, brute force it to get Ethan's password. This is the encrypted part. So you see how we make Ethan deliberately vulnerable and then use that vulnerability against Ethan to grab something. Now, what I'm going to do is I'll put it in like a, oh, it's already in a file called a.text. Now we're going to use John again. Um, and see if we can crack it. We can. This is Ethan's password. Let's go. Let's verify it, right? Go back, go back, go back, go back. Ethan, password. And we have correct password. We're going to be methodological. We'll put Ethan and password inside our creds.txt file. We can do just like before, a for proto thing for Ethan as well. We'll do it, but we don't really need it because we already know the escalation path from Ethan, right? You remember it? It was this from Emily, take over Ethan. Ethan can DC sync. So we can basically DC sync and take over the domain right now. But we still did it and for the fun of it. All right. Now how do we abuse DC sync? Again, NXC. NXC. Let's see. Let's see the doc. This is the easiest way to pull do DC sync, but there are some caveats to it. Okay, so um, let's do it and let's see if we run into those caveats or not. If we don't, then cool. If we do, we'll figure something out, right? That's what we do. So we want to grab the entire NTDS file using DC sync because Ethan can DC sync. And I'm going to explain what DC sync is in a second here. Oh, it worked. The caveat didn't stop us. So the caveat I was talking about is this part. Because Ethan is not a domain admin, it should not be able to dump the entire entities file, but we still were able to do it. Now the idea is all the domains have different domain controllers. Like a domain will have multiple domain controllers, okay? And multiple domain controllers mean they will have information stored in them and they will be out of sync, right? One domain controller would be the PDC, the primary domain controller, and that will have all the updated information. The other DCs, other domain controllers, they want to be updated. How do they do it? They use this thing called replication service. This replication service this Um, DRS, Directory Application Service, basically takes all the data from one domain controller and syncs it with the other ones. DC sync is basically the same thing. We are pretending to ask for a replication service and we replicate everything and we just take out the important part, important bits for us. All right, so we have dumped the NTDS file. Why did we go for NTDS? Because NTDS is a database that holds all the users and their passwords and their hashes. So we have the administrator user and their hash. Now, this user is basically, so there are two parts to this hash. This is the user name, then the SID, and then there will be this blank part, which is the LM part, and this is the NT part or NTLM part. So this is the part that we need. We don't need the other parts. Why? I have like a whole blog written about it, how different kinds of hash work in Active Directory and stuff like that. So let's not get into that. Let's not get distracted. Let's enjoy taking over the domain. So we want administrator. We're going to do this. Hopefully this works. It works. We have pawned as administrator, in the administrator.htb domain. So we're basically the domain admin here. If you don't believe me, you can do this like who am I / all. And you can see that you are in the built-in administrators group and you're also in the domain admin group. And the domain admin is the ultimate for a domain. So just for the fun of it, let's do evil winner impy and let's get in as administrator and grab our proof, right? That's always the fun part. I don't care about learning, I just care about submitting my flag. Cat root.text. Let's go. Solve. So the things that I want you to take away would be the basic idea of how to enumerate an Active Directory network. I'll just list them out actually. How to enumerate AD, SMB, and LDAP, two crown jewels of Active Directory. Learn the tool netexec, Kerberoasting, and targeted Kerberoasting. How to use BloodHound. That is very important. These 5 things would probably be the learning point of this machine. All right, it was fun, lots of struggle. See you in the next one with more struggle.